Chapter 15, number 66. Find the pressure difference on an airplane wing if air flows over the upper surface with a speed of 125 meters per second and along the bottom surface with a speed of 109 meters per second. And then find, say, if the area of the wing is 32 meters squared, what is the net upward force exerted on the wing? So, our first thing will be to draw a picture and see what's happening. Here we're going to use Bernoulli's equation that the pressure at one place plus a half times rho times V1 squared of that place is, plus a height term, is equal to pressure 2 plus 1/2 rho V2 square. And here, because they give us no information about the depth of the wing, I'm going to assume it's small enough that there's no contribution from the rho GH term. So hopefully that's true. And then we want the pressure difference, right, between the two. So I'm going to find, we should point out which of these is which. This is pressure 1, obviously, and this is pressure 2. And I'm going to find pressure 1 minus pressure 2, which is going to be, if we just solve these things over, 1/2 rho V2 square minus 1/2 rho V1 square. And so we put in some numbers. We're in an airplane, so the density of air is probably not what it is at sea level, but we're going to pretend, since we know nothing else, that it is at sea level. And so we're going to use the textbook version, which Walker gives us a standard density is 1.29 kilograms per meter square. It really should be probably something a little bit less because we're higher up, but again, we don't know anything, so we're going to go with this as it is. And then the speeds were given as the upper one was 125, and we need to square it, and the lower one was 109, and we need to square it. This is 2414.88 pascals. We have only 3 figures, right? We have 3 sig fig there, we have 3 sig fig there, and we're going to lose a sig fig in the next section, but right now we can stick that we have 3, and so it's 2410 pascals. It's part A. And then part B says what is the net force, which is going to be the force due to the bottom pressure, which is P1A, minus the force due to the top pressure, P2A, because our wing is essentially suffering an upward force from the bottom guy and a downward force from the upper guy. Again, they sort of mean the net force due to the air pressure, because of course there's also the weight of the wing. This is how it actually keeps the plane suspended in air. But they really just want to know what force is the air providing. That will tell you how much you could load the airplane. And so going back up here, we see that net force is the difference in area and forces. I'm going to do one extra step and pull out the common area. I'm going to do that in part because part A gave me P1 minus P2. And so it's going to be 2410 pascals times 32 meters squared, which turned out to be 77,120 newtons. Now we only have 2 digits, and so I should really call this 77 kilonewtons, which gives me my accuracy exactly as much as I need it. So there we go.